Hello everyone. Let us discuss Gram-Schmidt orthogonalization procedure to, to find orthogonal basis vectors for the given set of vectors and plot the orthonormal vectors. So what is the objective? So first you have to derive orthogonal basis vectors from a given set of non-orthogonal vectors using the Gram-Schmidt process. Second step is to compute the corresponding orthonormal vectors by normalizing the orthogonal vectors derived through Gram-Schmidt process. The last step is to visualize the orthonormal vectors by plotting them to understand their spatial distribution in the relation to the original vector set. So let us discuss what is orthogonal vectors. Two or more vectors are said to be orthogonal if they are perpendicular to each other. The meaning is that the angle between them is 90 degrees. Mathematically, we can say the dot product between vector u and vector v equal to 0. So let us take a simple example. Vector u has element 1 and 0 and v has element 0 and 1. The dot product equal to 0. So like that, orthonormal vectors. A set of vectors is orthonormal if the vectors are both orthogonal, that is first condition. Second condition, each vector has a unit length or norm of 1. So mathematically, the first condition should be orthogonal to each other. The second condition, norm, or it has a unit length equal to 1. In this example, u has element 1 and 0 where v has element 0 and 1. The norm or the length equal to 1. So you have to take a square root, then each element you have to do square, then you have to add. Okay, you have to add. So that time you will get the answer. So if answer is 1, we said orthonormal vectors, otherwise not. Yes, let us discuss how to convert a given set of non-orthogonal vectors to orthogonal vector. We have a vector space V. It has element v1, v2 up to vn. So we have a set of formula. So u1 equal to orthogonal vector. The first element as it is, the second element you have to subtract v2 minus the inner product of v2 into u1, again inner product of u1 into u1 multiplied by u1. Okay, so this is the way we are converting our non-orthogonal basis vector to orthogonal basis vector. So let us take one example where we have a Euclidean space R3 where v1 has element 1 minus 1 1, where v2 1 0 1, v3 equal to 1 1 2. So the first step is to convert orthogonal vector is u1 equal to v1. Okay, as it is, there is no change. Second step, u2 equal to v2 minus v2 dot product of u1, dot product as well as inner product both are same. Here dot product u1 into u1. So let us construct. So v2 equal to what? 1, where u1 equal to 1, 1 into 1, 1 into 1 plus second element is 0 and second element is minus 1, 0 into minus 1 plus 1 into 1. Okay, then dot product of u1 into u1, that is almost 1 into 1, that is 1 plus minus 1 into minus 1 plus 1, again 1 into 1, 3. So total 3. So 2 by 3 multiplied by u1, that is 1 minus 1 1, and you have to subtract with 1 0 1. In this way you can find second element, that is u2 equal to 1 by 3, 2 by 3, 1 by 3. Like that you have to find third element, that is minus 1 by 2, 0, 1 by 2. So this is the way we are converting a given set of non-orthogonal vectors to orthogonal vectors. The second step is to find orthonormalization. Okay, orthonormal vectors or orthonormal basis. How to find? For that you have to divide each vector by its length. So what we did here, so u1, that is the orthonormal vector, you have to divide it by its length. How to find length? What is the first element? 1 minus 1 1. You have to take square root of each element and then you have to add 1, then minus 1 square plus 1. So finally you will get root 3. Correct? Yes. In this way you will find orthonormal basis function or basis vector. It's like that we took a second example. The result will be here. So this example we took in the MATLAB. So same example we'll discuss in the MATLAB. So let us open a MATLAB. Yes, this is the MATLAB program. So now we will explain step by step. I will set a breakpoint. Okay. Yes. Now, so first you have to enter the elements of matrix. So this is the elements what we discussed here: 1 1 1, 1 2 1, 1 2 0, 1 1 1, 1 2 1, 1 2 0. So now the second instruction is n comma k size of A. So here n is number of rows, number of columns, that is 3 into 3 matrix. Okay, so A equal to, now A equal to 1 comma 1, 1 1 1, 1 2 1, 1 2 0, where n and k become 3 into 3. Now next the new matrix, name it as U. So U equal to zeros of n comma k. That means U has an element 0 0 0 0 0 0 0 0 0, 3 into 3. Yes, so this is 3 into 3 matrix, name it as U. Next, so this instruction indicates first column of U matrix. What is the first column of U matrix? 0 0 0. The first column of U matrix is 0 0 0. This is going to change by this function. So first function is A of 1. What is A of A is to of 1? That means first column of 8th matrix. What is the first column of 8th matrix? 1 1 1. Then normalization of A matrix of first column. So you have to do normalization. Correct? So what is norm of A111? So norm of A11 equal to what? Square root of 1 square plus 1 square plus 1 square, that's equal to square root of 3, that's equal to 1.73. correct? So now you have to divide A of 1 means first column. The first column is 1 1 1 divided by 1.73. So what is 1 by 1.73? It is 0.57334. So when you execute this step, see the first column of U matrix. What is the first column of U matrix? 0.5774, 0.5774, 0.5774. That is the first column of U matrix. Next step is to, this is the normalization we did. The second step is to, actually this step is to convert orthogonal vector. Okay, let us discuss. So for I equal to is to k. So what is k? K equal to 3. What is iteration? I equal to 2, first iteration. Second iteration I equal to 3. I will become 3. So now I equal to 2, you can observe here I equal to 2. Now u of I, what is u of I? That is second column of U matrix. Second column U matrix is 0 0 0. That's equal to, what is I equal to 2, that is second column of A matrix. What is second column of A matrix? That is 1 2 1 1 2 1. So you can observe the, see 1 2 2, sorry 1 2 2 2, that is the second column of U matrix. Now for j equal to I is to I minus 1. So what is I equal to 2, 2 minus 1 equal to 1, so j equal to 1. So actually what you are doing here, we are doing, it is used to make the vector u of I orthogonal to the vector u of j, correct? The operation removes the component of u of I, that is I equal to what here, I equal to 2, that is second column, that lies in the direction of u of j, where j equal to 1, making u of I, that is second column of U matrix, orthogonal to u of j. J means first column. Okay, so this is actually we are converting orthogonal vector. So this is the function where we are converting orthogonal. Okay, next, yes, the next step is to u of I. What is u of I? I equal to 2, second column, that is will be, we are converting here, we are converting non-orthogonal to orthogonal. Then here again you are doing normalization procedure. So u of I, so u of I equal to 2, that's equal to u of I equal to 2 divided by norm of u of I. So norm of u of I equal to second column. Okay, second column as it is. How to find normalization? Square root of, you have to take square root of the sum of the squares of its component. So in this way we are doing non-orthogonal procedure to orthogonal procedure, then we are doing normalization with the help of Gram-Schmidt procedure. So next you have to display U matrix. This is the display U matrix, this is the display of R matrix. How to find R matrix? A into, that is the input matrix into transpose of U. Okay. So like that, second iteration, I equal to 3, now I will become 3, I will become 3, it will do for third column. Yes, so this is U, what we are expecting, this is the U, and this is R matrix. Then we have to third step is to visualize, you have to plot the graph. So here scale equal to 0, so this sets the scaling factor for the arrow to 0. Then QR3, so in the context of QR3, a scaling of 0 means that the arrow will not be automatically scaled by MATLAB. So here QR3 0, 0, 0, the first three argument 0, 0, 0 specify the starting point of the arrow, which in this are in the origin. So it starts from origin 0, 0, 0. Then you have a u1, 1, u2, 1, u3, 1. These three arguments represent the components of the vector being plotted. Here u of 1, 1, u of 2, 1, u of 3, 1 are the elements of the first column of the matrix U. So this is indicates first column, first element, first column second element, first column third element. Okay, then here color equal to red color, so line width, that means thickness equal to 2. So like that, q over 3, here second column first element, second column second element, second column third element, like that q over 3. Then you are plotting, you are giving the label xyz and title and view 8,15. It will set the viewpoint of a 3D plot in MATLAB. I will run at a time. Yes, this is the plot. So thank you.